Okay, hey guys, I'm back. Decided to do another vid. I've been monitoring this stuff pretty much daily, at least once a day, and there haven't been any super big changes, so I decided not to make video. But today I noticed that the wind speed's back up again at certain points, and there's just a tiny bit of missing time. But as you can see here, here's the solar wind speed. This is apparently being recorded by these GOES satellites that go around here in the geosynchronous orbit at 22,236 miles above the Earth, because all the solar wind that's being recorded by the Discover satellite, which is out here at the L1 Lagrange point, which is way out here. Here's the Earth, here's the Sun. This isn't a true to scale representation, but these Lagrange points are, this one's 930,000 miles from the Earth, and the satellite stays right here 24/7 between the Earth and the Sun. These are some of the other spots where they can park satellites and they'll remain in a stationary orbit. We have the stereo behind telescope out here, SOHO, and the stereo ahead out here. Supposedly this one's down, but we're still getting data from it on the WSA Enlil CME simulations, which I don't know if I have time to show you today. Anyway, this is all on this solar ham space weather tutorial, and it'll give you a pretty good explanation of some of the stuff that's going on these graphs, like solar wind speed, the phi angle, which is key. The phi angle has been pretty much indicating a well, anytime it goes above 180, that means we're having a connection with something behind the sun, behind the Earth, another solar body. But if it's 180 or below, it's a Earth-Sun to connection or a Sun to the Earth connection. So it's been relatively stable the last 24-hour run. But here's the solar wind speed. So as you can see, gives you the time. See the time down here? 1600 UTC. So the solar wind speed that I'm going to show you on the ISWA was at 1956 UTC. I got to bring it up a little higher here so you can see it. The solar wind speed should pop up here when I'm the time. There's the time. See the time? So at 1956, the solar wind speed being registered on ACE was, and there's like a 15-minute up to an hour lag. Is this supposed to be an early warning of what's coming from the sun? So even if we go back 15 minutes or an hour, still nothing above 577. But on ISWA here, we're getting a solar wind speed reading of 1,017 kilometers per second. Now, the normal is between 400 and 700. It doesn't really go much higher than that. And they have this thing calibrated in 50s today because the solar wind has been up some with this coronal holes facing the Earth the last few days. So there we go. There's the 1017. Now you can see here's the arrows coming in from something behind is exerting a whole lot of pressure. And you can see here that we got a whole lot of electrons bleeding in around the Earth. And this is the 22,236 mile geosynchronous orbit. And these dotted lines here, and you can see we got a ton of low energy electrons bleeding in. which they're the slowest moving electrons, and they're measured at 10 keV. And we also have a lot of high energy electrons bleeding in, which are the ones that move the fastest. And they're being measured at 4,000 keV or 4 MeV. So these two are synced together. These three are synced together. Can't get them all synced together because these things run a different calibration. But you can see the planet's being constantly bathed in pretty high electron counts. So let's get back to here. So you see this is the sun's out here, so we get the solar wind pressure coming from this way, the velocity. You can see even there it's 799. So and this is of course our magnetopause and our magnetosphere. You got the black polar cap field lines. They pretty much just stream away from the Earth and be like a shield from the solar wind pressure. And as you can see, we're getting more solar wind pressure from our sun, which is indicated here. And I think that's causing the magnetosphere to buck up and have to concentrate more power in the front, because that's what it normally does anyway. And if you remember some of the last couple of videos I showed you, these closed field lines, which normally just maintain pretty close proximity to the Earth around the polar caps. See how they close at each polar cap? That's where you get the auroras from. And they occur more often, when there's like right now, we're having elevated solar wind pressure from the coronal holes facing the Earth. But I showed you last week in some videos that these closed field lines were extending way out here. And these are Earth radii. So this is 80, 100 Earth radii. And an Earth's radius is about 3,959 miles. So this is around 400,000 miles. You can see this closed field lines going way back here. And this is at where the solar wind speed I showed you was at 1019. Same time here. So you can see there's something going on here, like a void. And there it is there. Now this shows you a shot from like a north-south shot. It's like a slice. So figure this is the Earth, and it's like an MRI. It's like a plane, a slice. It's just a cut going across the Earth and across the magnetopause and the magnetosphere, and then they're turning it on its side, and we're looking at it from up-down position. So these arrows indicate direction of the solar wind, and of course they should always be flowing from right to left, because that's where our sun is. But now that we have Nemesis in the neighborhood, which is the binary twin to our sun, and our sun emits mostly protons, so conversely Nemesis emits mostly electrons in the equal opposite theorem from way back in Newton day. He's the one that came up with that, and it pretty much makes sense. So anyway, this is where we're getting all the electron stuff from. And I have this one at the 1956 too. So let's just play around with this. Here I'll show you the closed field line. So what I was wanting to point out was, if you watched the videos last week, we were getting some serious closed field lines, red, way out here, a whole bunch and a bunch and a bunch, but we weren't getting much solar wind pressure from the sun. So the magnetosphere was bucking up and gearing all of its energy to fight off Nemesis, which was coming from the back, all this pressure from the back. And they were making these huge closed field lines in red way out past even the 400,000 mile mark to expel the energy from Nemesis. But now that it has to concentrate more energy on the front, the sun side, to take care of the extra solar wind coming in from the coronal holes, you can see there's far less closed field lines or magnetosphere power behind the Earth, it would appear. But you can still see we still have a ton of solar wind pressure coming from the backside. So these field lines should be showing like last week. And look how this magnetopause is getting all twisted because of the backside pressure and the front side pressure, and it's, I'm sure it's like super turbulent magnetically speaking. So you can see if I just pull this through real quick, all the backside pressure coming through. And there it is at around the time the solar wind speed came up. And same here. So you can see that red field lines, we're not getting too many behind anymore. So these black field lines are having to ball up and eject this plasma and so forth that's building up behind the Earth. I'll run this through real quick. And I saw just a little bit of missing time around the, what was it, the 22? Anyway, you can play with it. I'll put the link below where you can pull up this whole run and you can play around with this stuff. Here's the MLSO stuff from the Mauna Loa Solar Observatory. As you can see, they've pretty much been blanked out 5 out of the last 6 days. Here's what I pulled up for Saturday the 6th after they sanitized it. They didn't put it up beforehand. You can see there's still something there, and you can still see some streamers running through even after they sanitized it. And we have quite a bit of missing time in here, which I don't have time to really get into. I'll put the link below. You can check it out. But I did do the math, and I added up the days. Out of the 281 days this year in 2018, this MLSO has been X'd out 118 of them, which amounts to 42%. Now here's the magnetic resonant grid pattern that I've identified way back as early as early June, but I think it was occurring much before that as well, because I identified a magnetic resonant grid pattern around the sun. This was on my April 6th video. If you want to go back and check that out, that's one of my key videos, I would say. So you can see it here, the magnetic resonant grid pattern showing up on the 304 angstroms on SOHO and on the 195 angstroms. And SOHO's back up, so we're getting the current readings. It was down there for a while. Then if you go to the SDO, this is the one that shoots from near the Earth. It's on the 22,000 geosynchronous orbit, offset from Earth. That's why sometimes you get these bodies going through, which happened back in early October when you saw I think the moon came down and then something else came through. So it had to be one of the Nemesis objects. You can see the magnetic resonant grid pattern here on the 94 angstrom and on the 335 angstrom. And this has been showing up on the planet every single day. This is what it looks like. So let me know if you want me to do a video on Michael, because they're clearly trying to geoengineer Michael and turn it into a major hurricane, and of all things they're going to steer it back up through North Carolina and South Carolina, which is going to really compound the problems they're already having. But they've been reporting that at 70 miles an hour this morning. You can see it's nowhere near that, so they're BSing you on that. But I'm running out of time, so let me know if you want me to do a video on this. And here's the next rad station out here pumping in energy into the atmosphere all over North America, which is elevating the atmospheric potential energy, and increasing the storm rates possible. Gotta go. Bye.